Preparing for a Spring Boot interview questions and answers interview? You've reached Interview Guide, and this video is for you. We'll walk through 21 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is Spring Boot, and how is it different from the Spring framework? Spring Boot is an opinionated way to build Spring applications faster. Traditional Spring often needs manual XML or Java configuration, dependency setup, and external server deployment. Boot simplifies that with auto-configuration, starter dependencies, embedded Tomcat or Jetty, and production-ready features like Actuator. I still use the Spring framework underneath for dependency injection, MVC, transactions, and security. Boot mainly removes setup friction and helps teams ship standalone applications quickly. While answering, focus on auto-configuration, starter dependencies, embedded servers, reduced boilerplate, opinionated defaults, and how Spring Boot builds on Spring rather than replacing it. Question 2. How does Spring Boot auto-configuration work internally? Auto-configuration means Spring Boot creates sensible beans based on what it finds in the application. If Spring MVC is on the class path, Boot configures a dispatcher servlet, message converters, and default web infrastructure. It uses conditional annotations like @conditional_on_class, conditional_on_missing_bean, and @conditional_on_property. The key point is that Boot backs off when I define my own bean, so I can accept defaults first and customize only where needed. Make sure to cover class path scanning, conditional annotations, auto-configuration classes, Spring.factories or auto-configuration.imports, bean creation order, and how custom beans override defaults. Question 3. What is the purpose of @Spring Boot application? Spring Boot application is a convenience annotation that combines @configuration, @enable auto-configuration, and @component scan. It marks the class as a source of bean definitions, enables Boot's automatic setup, and scans components from the package where it is placed downward. In real projects, I keep the main class at the root package, so controllers, services, repositories, and configurations are discovered naturally. If scanning is wrong, beans may not load, and dependency injection fails. In your answer, talk about the 3 composed annotations: component scanning boundaries, configuration class behavior, auto-configuration trigger, and why package placement matters in real projects. Question 4. What are Spring Boot starters, and why are they useful? Starters are curated dependency bundles for common application needs. For example, Spring Boot Starter Web brings Spring MVC, validation support, JSON handling, and an embedded server without me listing each library manually. The biggest value is compatibility. Spring Boot's dependency management aligns versions that work together. That avoids dependency hell and speeds setup. I still can exclude or override dependencies, but starters give a clean default baseline for web, JPA, security, testing, messaging, and more. Be sure to mention dependency aggregation, version compatibility, reduced Maven or Gradle complexity, common starters like web, data JPA, security, test, and how Boot manages transitive dependencies. Question 5. How do you manage configuration in a Spring Boot application? Spring Boot encourages externalized configuration, so the same artifact can run in dev, staging, and production. I typically use application.yml for structured config, profiles for environment-specific values, and environment variables in containers. For group settings, I prefer @configuration properties over scattered @value fields because it is type-safe and testable. Secrets should not live in Git. They should come from a Vault, Kubernetes secrets, or a secure cloud configuration service. While answering, include application.properties versus YAML, profiles, environment variables, externalized configuration, @configuration properties, @value, configuration precedents, and secrets management best practices. Question 6. What are Spring profiles, and how would you use them in production deployments? Profiles let me activate different beans or configuration values based on the runtime environment. I might have application dev.yml using H2 and verbose logging, while application prod.yml uses PostgreSQL, secure logging, and production pool sizes. Profiles can be enabled through spring.profiles.active, environment variables, or command line arguments. I avoid creating too many profiles for small differences. Those should be normal properties. Profiles are best for meaningful environment or infrastructure differences. Make sure to cover environment-specific beans, profile-specific property files, activation methods, avoiding profile explosion, testing profiles, and differences between build time and runtime configuration. Question 7. Explain dependency injection in Spring Boot and the difference between constructor, setter, and field injection. Dependency injection lets Spring create objects and supply their collaborators, instead of classes constructing dependencies directly. Constructor injection is my default because it makes dependencies explicit, supports final fields, improves testability, and fails fast when required beans are missing. Setter injection is useful for optional dependencies or reconfiguration. Field injection is concise but hides dependencies, complicates unit tests, and relies heavily on reflection. In production code, constructor injection usually gives the cleanest design. In your answer, compare injection styles, immutability, testability, required versus optional dependencies, circular dependency detection, and why constructor injection is usually preferred. Question 8. How does the Spring Boot application startup process work? Startup begins when Spring application.run is called from the main method. Boot prepares the environment, loads properties, creates the application context, scans components, applies auto-configuration, and initializes beans. For web apps, it then starts the embedded server and registers the dispatcher servlet. After the context is ready, application runner or command line runner beans execute. Most startup failures come from missing properties, bean conflicts, failed database connections, or incorrect component scanning. Be sure to mention Spring application.run, environment preparation, application context creation, bean scanning auto-configuration, embedded server startup, runners, and common startup failure causes. Question 9. What is Spring Boot Actuator, and how do you use it safely? Actuator adds production monitoring endpoints to a Spring Boot application. I use it for health checks, metrics, build info, environment insight, thread dumps, and readiness or liveness probes in Kubernetes. The safety part matters. I expose only required endpoints, protect sensitive ones with Spring security, and avoid publishing environment or bean details publicly. In real systems, Actuator plus Micrometer gives a strong foundation for dashboards, alerts, and incident debugging. While answering, focus on operational endpoints, health checks, metrics, info, environment exposure risks, endpoint enablement, security integration, Kubernetes readiness, and liveness probes. Question 10. How would you create a REST API in Spring Boot? I usually create a @REST controller, define endpoints with @GET mapping, @POST mapping, and related annotations, then delegate business logic to a service layer. Requests and responses should use DTOs rather than exposing entities directly. I add validation using @valid and bean validation annotations, return meaningful status codes, and handle errors through @controller advice. Jackson handles JSON serialization by default. This keeps the API clean, testable, and separated from persistence concerns. Make sure to cover controller annotations, request mapping, DTOs, validation, response status codes, service layer separation, exception handling, and JSON serialization with Jackson. Question 11. How do you handle exceptions globally in Spring Boot? Global exception handling is usually done with @controller advice and @exception handler methods. Instead of scattering try-catch blocks across controllers, I map domain exceptions, validation failures, and unexpected errors into a consistent error response. For example, resource not found exception returns 404, validation errors return 400, and unknown exceptions return 500. I log enough for debugging, but never expose stack traces or internal database details to clients. Good error design improves both security and API usability. In your answer, mention controller advice, exception handler, consistent error response models, HTTP status mapping, validation errors, logging strategy, and avoiding leaking internal details. Question 12. What is the difference between @component, @service, @repository, and @controller? Component is the generic stereotype for a Spring-managed beam. @service, @repository, and @controller are specialized forms used to express intent. I use @service for business logic, @repository for persistence classes, and @controller or @rest controller for web endpoints. @repository also enables translation of persistence exceptions into Spring's data access exception hierarchy. Technically, they all create beans, but the specialized annotations make architecture clearer and allow framework-specific behavior where needed. Be sure to explain stereotype annotations, component scanning, semantic intent, repository exception translation, controller request handling, and why clear annotation choice improves readability. Question 13. How does Spring Boot work with Spring Data JPA? Spring Boot auto-configures JPA when it detects Spring Data JPA, Hibernate, and a data source. I define entities with @entity, create repository interfaces extending JPA repository, and get CRUD operations plus derived queries without boilerplate. For complex cases, I use JPQL, native queries, or specifications. Transactions usually live at the service layer with @transactional. The main pitfalls are N+1 queries, lazy loading outside transactions, and exposing entities directly through REST APIs. While answering, cover repositories, entity mapping, Hibernate integration, data source auto-configuration, transaction management, query methods, JPQL, native queries, and common pitfalls like lazy loading. Question 14. What is @transactional, and what issues can occur if it is used incorrectly? Transactional defines a transaction boundary around a method, usually in the service layer. By default, Spring rolls back on unchecked exceptions, but not checked exceptions unless configured. Common mistakes include putting it on private methods, expecting it to work during self-invocation, or placing transaction logic in controllers. Since Spring often uses proxies, calls must go through the proxy. I also pay attention to isolation and propagation when multiple database operations interact. Make sure to cover transaction boundaries, rollback behavior, runtime versus checked exceptions, propagation, isolation, proxy limitations, self-invocation, and service layer placement. Question 15. How would you secure a Spring Boot REST API? For a REST API, I start with Spring Security and define a security filter chain. Authentication might use JWT, OAuth2, or session-based login depending on the architecture. Authorization should be role or permission-based, ideally enforced at both URL and method levels. Passwords must be hashed with a strong encoder like bcrypt. For stateless APIs, I usually disable CSRF only when appropriate, configure CORS carefully, and never rely on client-side checks for security. In your answer, discuss Spring Security Filter Chain, authentication, authorization, JWT or OAuth2, password encoding, CORS, CSRF considerations, method security, and least privilege. Question 16. How do you test a Spring Boot application effectively? I split tests by scope. Unit tests cover services with mocks and run very fast. Slice tests like @WebMVC test validate controllers without loading the full application, and @Data JPA test checks repository behavior. For end-to-end wiring, I use @Spring Boot test, but sparingly because it is heavier. When databases or brokers matter, test containers gives realistic integration tests. A strong test strategy balances speed, confidence, and coverage of framework configuration. Be sure to mention unit tests, slice tests like @WebMVC test and @Data JPA test, @Spring Boot test, mocking, test containers, profiles, and keeping tests fast and reliable. Question 17. What are the common ways to improve performance in a Spring Boot application? I start performance work with measurements, not guesses. Common wins include fixing slow database queries, adding indexes, using pagination, tuning Hikari CP connection pools, and avoiding N+1 queries. Caching helps for frequently read, rarely changing data. For long-running work, async processing or messaging can protect request latency. I also monitor JVM memory, garbage collection, thread pools, and Actuator metrics. The best optimization depends on the actual bottleneck, not a generic checklist. While answering, cover database query optimization, connection pooling, caching, pagination, async processing, JVM tuning, reducing startup cost, metrics-driven decisions, and avoiding premature optimization. Question 18. How does caching work in Spring Boot? Spring Boot caching is annotation-driven. After enabling caching, I can use @cacheable to store method results, @cacheput to update cache entries, and @cacheaveg to remove stale data. The actual provider might be Caffeine, Redis, eCache, or another implementation. The hard part is not adding a cache. It is choosing keys, expiration, and invalidation rules. I avoid caching highly volatile data unless I can tolerate temporary staleness. Make sure to cover @enable caching, @cacheable, @cacheput, @cacheevict, cache providers, key design, TTL, invalidation, stale data risks, and when caching is inappropriate. Question 19. How would you implement asynchronous processing in Spring Boot? For lightweight asynchronous tasks, I enable async support and annotate methods with async. I configure a custom executor instead of using defaults, because thread pool size, queue capacity, and rejection policy affect production behavior. Methods can return completable future when callers need results. I also handle exceptions explicitly, because async failures may not surface normally. For durable, high-volume background work, I prefer a message broker like Kafka or RabbitMQ over in-process async. In your answer, include @enable async, @async, custom executor configuration, return types like completable future, exception handling, thread pool sizing, and when messaging is better. Question 20. What is the difference between Spring MVC and Spring WebFlux in Spring Boot? Spring MVC is the traditional blocking web stack built on the Servlet API. It is simple, mature, and works well for most CRUD applications. WebFlux is reactive and non-blocking, using reactor types like Mono and Flux, often running on Netty. It helps when handling many concurrent I/O-bound requests, such as gateway or streaming workloads. The catch is that blocking database calls inside WebFlux remove most benefits, so the whole stack should be reactive. Be sure to compare blocking versus non-blocking models, servlet stack, reactive streams, Netty, back pressure, use cases, learning curve, and why mixing blocking calls hurts WebFlux. Question 21. How would you design and deploy a Spring Boot microservice for production? I would keep the service focused on one business capability, with clear controller, service, and persistence layers. Configuration should be externalized, secrets managed securely, and database ownership explicit. For production, I add Actuator health checks, metrics, structured logs, tracing, security, and resilience patterns like timeouts and retries. I package it as a container, deploy through CI/CD, and scale horizontally behind a load balancer. Graceful shutdown and readiness probes prevent traffic during unsafe states. While answering, cover layered architecture, configuration, database boundaries, observability, resilience, containerization, health checks, security, CI/CD, scaling, and graceful shutdown. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.